Alright, so sample exam 1, number 22. We have a differential equation, dy dx equals x squared plus y squared. But in this particular case, we don't need to solve it. We need to find the second derivative. So if we know the first derivative, dy dx equals x squared times y squared, to find the second derivative, we would just need to differentiate, which ultimately means that if we differentiate the left, we get d squared y dx squared, which is the second derivative notation. And then if we differentiate this, we'd have to recognize that it's a what? It's a product. So if we go first times the derivative of the second plus the second times the derivative of the first, we'd have that. And ultimately we'd get 2x squared y dy dx plus 2xy squared. And ultimately that's not an option though, is it? And if not, why not? What is this? Isn't this equal to x squared y squared? So if I put in that, I would wind up with 2x to the fourth, y to the third, plus 2xy squared. And is that an option? And that letter E? Okay, questions? Others? 1 through 28. Six, we have a piecewise function made up of two line segments, x when x is less than or equal to 0, x plus 1 when x is greater than 0. And ultimately we're looking for the value of the integral of x, f of x, negative 2 to 1. Alright, so let's see if we can come up with an answer for this here. We, keeping in mind that we have an issue here at 0, so the function itself is made up of two different line segments, and if you can draw yourself a picture, that might be helpful. So ultimately it's x when we're less than 0, x plus 1 when we're greater than 0, so should draw those with the same slope, but regardless, we'd have something like that. And so the area from negative 2 to 0 would be that, and the area from 0 to 1 would be something like that then, wouldn't it? So in this particular case, since they're line segments, you could use shapes here to figure out those two areas if you so chose. Couldn't you? That'd be the easiest way. You got a triangle on the left. It's y equals x to the left. Ultimately, again, we're going to 2 over here. So this is negative 2, so that means it's 2 by 2 triangle. So if it's 2 by 2 triangle, that means it's a half times 2 area. So ultimately it would be 2. Keep in mind though that the area would be negative 2 for that part. It's in the below part, below the x-axis. And then for this part here, we got an x plus 1. 1, this would be a height of 2, that would be a height of 1. Base of 1, that is. The height here would be 2, so if we used our trapezoid formula, be 1/2 times 1 times 1 plus 2. And if we did the math on that, we'd get 3/2. So ultimately the total area then would be triangle plus trapezoid, which would be negative 1/2. Negative 2 for this part, 3/2 for that part, give us negative 1/2. And ultimately that is not an option, so what did we do wrong here somewhere? Let's find out. No, never mind. It's x f of x. This would be just f of x only, so scratch that. Alright, so x f of x. Let's try that again. So with that, again, keeping in mind though that we know that we still have an issue here at 0, so if we separate these integrals and we did from negative 2 to 0 of x f of x, wouldn't that just be x squared dx then? Again, f of x would be x in that area. So if we use the fundamental theorem instead of using a area formula, we'd ultimately get 0 minus, and then putting a negative 2 in there, we get negative 8/3. So we get 8/3 as our area for that part. Again, x f of x on negative 2 to 0 is just x squared, because that's on negative 2 to 0, our function is x. So x times x would be x squared. If we anti-differentiate, plug in our 0 and our negative 2.
So are you separating it into two separate integrals?
Yeah. And then we'll do another integral from 0 to 1, x times x plus 1 dx, because our f of x in that area is x plus 1. And so ultimately that'd be x squared plus x, so x cubed over 3 plus x squared over 2.
Please come down to the office for their field trip. AP Lit students, please come down to the office for your field trip.
And so if we, again, if we multiply our x times our f of x, x plus 1, we get x squared plus x. And plugging into 1, we get a third plus a half minus 0, because the zeros would make zeros there. A third and a half would be 3/6 and 2/6, 5/6. And ultimately, if we add these two together, we get, this would be 16/6, would be 21/6. 21/6 is 7/2, which ultimately is D. Alright. Questions on that one?
Can I go to my field trip?
You're kind of already going, aren't you?
Yeah.
See ya.
Okay, bye.
Alright, what else? Under
28.
And 28, we got a substitution problem, which is exactly what we're doing right now. They let us use, want us to use that as our u. And our integral here is from 2 to 8, 1 over radical 2x plus 1 dx. So, ultimately, if we do our substitution here, and we let our u be exactly what they said, we'd have u plus 1 here, but we still have a dx right here. True? Alright, so the question is, what can we do then? Because this is not going to be something we can integrate with our u plus 1, that seems fine, but then dx is our issue here. So if we did our du over here with our radical 2x, keep in mind that's 2x to the 1/2, we'd have 1/2 times 2x to the negative 1/2 times 2, which ultimately would give us 1 over radical 2x as our derivative. So that right there would be our du. True? Alright. So, bottom line here is there any way we can get rid of that dx? Well, radical 2x du is going to, or radical 2x du, I should say, is going to be equal to dx if I multiply. So I certainly could replace that. Let's see what happens if we do. We got u plus 1, we got radical 2x dx here. Alright, so again, I lied, this is du, sorry. Radical 2x du. So again, the issue is we still have that radical 2x in there, but what does radical 2x equal? Doesn't it equal u? So if we go u over u plus 1 du, we can get the x's out of there, can't we? Alright, so now the question is though, can we do anything with that? Can we anti-differentiate that, in other words? Is it a known derivative? It's not, is it? If it's not a known derivative, then our next step is to use substitution then, isn't it? True? first place, but it's still not a known derivative. So our next step in general has been substitution. So we could try to substitute again, and if we did so, we'd use another dummy variable like w, if you will. And if we let, say, w equal u plus 1, we could try that maybe, see what happens. If we did, then dw would equal just du. So let's see what happened if we change that. We'd have a w here, we'd have a du here, but we'd still have a u on top, wouldn't we? But what does u equal? If we solve this sentence, wouldn't w minus 1 equal u? So couldn't we put w minus 1 then here instead of u? And now it's a little bit nicer because we can now rewrite it as w over w minus 1 over w dw. This is the w, sorry. Which ultimately means I can go 1 minus 1 over w dw. And now it's something I can integrate because now the integrand here is 1, which its antiderivative with respect to w is what? W. And the antiderivative of 1 over w is ln w, absolute value of, that is. Okay. And so with the two substitutions, we just substitute again, and ultimately we were able to get it into a form that we could find an antiderivative for, which was ultimately the goal. Okay. So with that, if we resubstitute our u or w's out of there and our u's back in, we'd have u plus 1 minus ln of absolute value of u plus 1. Still bars there because we're still not an x. Okay. So if we put our x back in there now, radical 2x plus 1 minus ln of absolute value of radical 2x plus 1. Now we can put in our 2 and our 8, if you will. 2 and 8. And so if we put our 8 in, we'd get 8 in here, give us 16. So 16 square root would be 4. 4 plus 1 would be 5. And then our natural log of, in here we'd have natural log of 5 also. Oh, I'm doing way too much work here, but I realized that we didn't even ask for the actual answer. So bottom line is if I put my 16 in there, I get a 5 in the parentheses here, so it'd be 5 minus ln 5. And then minus, if I put a 2 in there, I'd get 4, so that'd be 2 plus 1 would be 3, minus ln 3. And with that, we'd have ultimately 2 minus ln 5 plus ln 3. So, and we could ultimately put that together too because we have ln 3 minus ln 5. We could write it as minus ln of 3/5. So that would be the final answer if that's what we were asked to do. But ultimately, we had the answer back up here, didn't we? So this was the right integrand because they just asked us to do the substitution part and not actually solve it. I'll look at the answers in there. So this would be the one here, which means that the only options at this point are C and D, it looks like. And why is it not C? Still got 2 and 8 on there. Ultimately, we have to change those to x values. So 8 in there would give us 4. 2 in there would give us 2. So the actual answers on this should be 2 and 4. And therefore, that would be the final answer. So it is integrable, though. We could find a final answer. Ultimately, I showed you how to do that. But the only thing they're asking for is just to get it to that point and then quit. Okay, with that time that we have tomorrow, we'll start working on the calculator part. So hopefully you have that done.